There are creatures in your house right now, with 8 legs, up to 8 eyes, built-in silk factories, and venom strong enough to liquefy their prey. But before you grab a shoe, what if I told you these tiny monsters are actually engineering geniuses, biological marvels, and possibly the reason you're not buried under mountains of insects right now? Yeah, today, we're talking about spiders, and by the end of this video, you might not love them, but you will respect them. First things first, spiders are not insects. They belong to a group called arachnids, which also includes scorpions and ticks. Unlike insects, spiders have 8 legs. Insects have 6. 2 main body segments, no antennae, and usually 8 eyes. There are over 50,000 known species of spiders, and scientists discover new ones every year. That means statistically, one of them might be named after you someday. There's literally a spider named after David Bowie. You're not special. Let's talk about spider silk. It sounds like something out of a comic book, but this incredible material is one of the most fascinating and sought-after substances in the natural world, and for good reason. Spider silk is one of the strongest natural materials on Earth. To understand its power, we need to look at 2 key properties: tensile strength and elasticity. Tensile strength is the maximum stress a material can withstand while being pulled apart. Elasticity is its ability to stretch and then return to its original shape. Spider silk has a mind-boggling combination of both. Pound for pound, it's 5 times stronger than steel and 3 times tougher than Kevlar. That means a strand of silk is much harder to break than a steel wire of the same weight, and it can absorb significantly more energy before it snaps. This leads to one of the most famous thought experiments in material science. If you had a single strand of spider silk, scaled up to be as thick as a standard pencil, it could theoretically stop a Boeing 747 jumbo jet flying at full speed. It wouldn't just snap the strand, the silk would stretch, absorbing the plane's colossal kinetic energy and bringing it to a halt. It's a testament to its almost unbelievable toughness. With properties like these, you can imagine the possibilities. For centuries, humans have dreamed of harnessing this power. We're talking about next-generation body armor that's lighter and more flexible than anything we have now. Ropes and cables for construction and aerospace that are a fraction of the weight of steel. In medicine, its potential is even more profound. Because it's a protein, it's biocompatible, meaning our bodies don't reject it. Scientists are developing it for everything from ultra-fine, dissolvable surgical sutures to scaffolds that could help regenerate nerves and ligaments. Which raises an important and slightly absurd question: why are we not building bridges out of spider butts? Well, farming spiders is a logistical nightmare. Unlike silkworms, which are docile, plant-eating and happy to live in close quarters, spiders are aggressive, territorial predators. Put 1,000 of them in a box and you won't get 1,000 spiders worth of silk. You'll get one very well-fed, victorious spider. They're cannibalistic, they do not cooperate in factory settings, and they produce a surprisingly small amount of silk individually. Basically, they're terrible co-workers. But scientists are clever, and they're not giving up. If you can't farm the spider, why not just borrow its recipe? Researchers have successfully identified the genes responsible for silk production and inserted them into other organisms. They're using genetically modified E. coli bacteria, turning vast vats of microorganisms into tiny, silk protein-producing factories. They've also engineered yeast and even silkworms to produce spider silk. And then there's the most famous example: goats. Yes, by inserting spider genes into a goat's DNA, scientists at Utah State University created goats that produce spider silk proteins right in their milk. The milk is then collected, and the proteins are filtered out and spun into a fiber. While we're not yet at the 747 stopping stage, the progress is astounding. We are on the cusp of a materials revolution, all by reverse engineering the work of an 8-legged architect, spiders, inspiring science, and confusing farmers. When you think of spiders, you think of webs. But here's the twist: most spiders don't actually build webs to catch prey. Many are active hunters. Wolf spiders chase their prey down. Jumping spiders pounce like tiny cats. Trapdoor spiders build hidden burrows and explode upward, like something from a horror movie. Imagine walking past your front door and the ground just opens. That's basically their entire personality. And jumping spiders, they're the puppies of the spider world. They have excellent vision and can recognize faces, even yours. So yes, somewhere out there, a spider might be judging you. When you think of superpowers, you probably think of X-ray vision or flying, but spiders have a suite of abilities that would make any comic book hero jealous, starting with their senses. Now it's true that most spiders have 8 eyes, though some have 6, and a few cave-dwelling species have none at all. But here's the twist. For many spiders, vision isn't even their most important sense. They experience the world in ways we can barely imagine. Let's start with the exception that proves the rule. The jumping spider. These little acrobats have some of the best eyesight in the entire arthropod world. Their 2 huge forward-facing principal eyes are like built-in binoculars, providing high-resolution, telescopic vision. They can see in color, which is rare for arachnids, and can even detect ultraviolet light. This might help them spot mates or see patterns on flowers and prey that are completely invisible to us. The other 6 eyes are motion detectors, giving them a nearly 360-degree view of the world. This incredible visual acuity is essential for their lifestyle. They are active hunters that need to stalk prey and make precision leaps across great distances. But other spiders? Not so much. Many web-building or nocturnal spiders have very poor vision. They basically see the world as a blurry collection of light and shadow. So how do they operate with such precision? They rely on vibrations, like tiny, 8-legged daredevils. Their bodies and legs are covered in exquisitely sensitive hairs called trichobothria. These aren't just regular hairs. They are sophisticated motion sensors that can detect the faintest vibrations and even subtle currents in the air. A spider in its web can feel the wing beats of a nearby fly before it even touches the silk. It can distinguish between the frantic struggle of prey, the gentle tug of a falling leaf, and the romantic plucking of a potential mate. They live in a world of pure vibration, a symphony of information that tells them everything they need to know, but sensing the world is only half the battle. To act on that information, they need to move. And then there's this. Spiders don't use muscles to extend their legs like we do. They use hydraulic pressure. Spiders have flexor muscles to pull their legs inward, towards their body. But to push them out? They don't have the corresponding extensor muscles. Instead, they contract their cephalothorax, the front part of their body, which rapidly increases the pressure of their blood, called hemolymph. This forces the fluid into their legs, causing them to straighten out with incredible speed and force. This hydraulic system is the secret behind a jumping spider's phenomenal leap, allowing it to launch itself many times its own body length. It's a biological marvel of engineering, and it also explains a common, slightly morbid observation. That's right, they pump fluid into their legs to move them. That's why dead spiders always curl up. Once the spider dies, the heart stops, the pressure system fails, and there's nothing to counteract those flexor muscles. The legs automatically retract into that classic curled position. So if you've ever wondered why they do that, now you know. Okay, let's address the fear. The fangs, the venom. It's the #1 reason people give for being scared of spiders, and honestly, it's understandable. The idea of being injected with a potent cocktail of chemicals is the stuff of nightmares. But like most nightmares, when you turn on the lights and really look at it, the monster isn't nearly as big or as scary as you thought. So let's turn on the lights. Yes, spiders have venom. It's true, almost all of them do. It's their primary tool for hunting. It's how a tiny creature can subdue an insect much larger and stronger than itself. Think of it as their superpower for getting dinner. In fact, there's an entire family of spiders, the Uloboridae, that are famous for being the rare exception. They have no venom glands at all. Instead, they wrap their prey so tightly in silk that they crush it. A bit grim, but venom-free. But here's the most important truth. Out of over 50,000 known spider species on Earth, only a tiny, tiny handful, less than half of 1%, are considered medically significant to humans. That means their venom is potent enough to require medical attention. We're talking about famous names like the black widow or the brown recluse. And even these species are incredibly shy and reclusive. They have zero interest in seeking you out. Spiders are not interested in you. You are too big. You are not food. To a spider, you are basically a walking, talking, breathing natural disaster. A warm, vibrating, unpredictable mountain. Venom is biologically expensive to produce. It takes time and energy. A spider isn't going to waste its precious hunting tool on something it can't possibly eat, unless it genuinely believes its life is in immediate danger. So when do bites happen? Almost always, it's because a spider was accidentally trapped and pressed against skin. You put on a shoe it was hiding in, you reached into a dark shed or a woodpile without looking. Or, the classic scenario, you rolled over in your sleep, it panicked, it couldn't run, it defended itself in the only way it knew how. In the vast majority of cases, a spider bite is less severe than a bee sting, resulting in minor localized pain, itching, and swelling. If you are bitten, the best course of action is simple: stay calm, wash the area gently with soap and water, and apply a cool compress. Of course, if you experience severe symptoms or you know the spider was from a medically significant species, seek professional medical attention. But for almost every spider you'll ever meet, that won't be necessary. You were the giant in the situation. And here's something truly wild. That same venom we fear is becoming one of the most exciting frontiers in medicine. Scientists are studying the complex proteins and peptides in spider venom to develop revolutionary new drugs. They've found compounds that can act as highly targeted painkillers, blocking pain signals in nerves without the side effects of traditional opioids. Other molecules show promise in treating neurological diseases like muscular dystrophy and even stroke by protecting brain cells from damage. So the very thing you fear, this ancient and powerful substance, might someday cure your chronic pain or help a loved one recover from a serious illness. Plot twist. Here's a fact that might change everything. Spiders eat an estimated 400 to 800 million tons of insects every single year. That's more meat than all humans consume annually. Without spiders, we would be drowning in flies, mosquitoes, and crop-destroying pests. They're silent pest control agents working 24/7 for free. No salary, no appreciation, just vibes and violence. And yet people still scream when they see one. Rude. Let's rapid-fire some things you probably didn't know. Some spiders can balloon through the air by releasing silk and riding the wind. They've been found miles up in the sky. Male spiders sometimes bring gifts, like wrapped prey, to females to avoid being eaten. It's basically spider dating culture. There are diving bell spiders that live almost entirely underwater, carrying air bubbles with them like scuba tanks. Peacock spiders perform elaborate dances to attract mates. Full choreography. Tiny interpretive dance icons. Nature really said, let's experiment. So yeah, spiders are weird. They're hydraulic-powered, silk-spinning, venom-injecting, gift-giving, interpretive dancing engineers. They hold ecosystems together. They inspire futuristic materials. They might help create new medicines. And statistically, one is probably within 10 feet of you right now. But maybe that's not a horror story. Maybe that's just a tiny guardian keeping the bugs away. So next time you see a spider, maybe let it cook. If you enjoyed this video, hit the like button, subscribe, and comment down below which animal we should explore next. And until then, stay curious.